And we are live. Yes, this is Doug. This is Math with Doug. We are learning percent. It is week 2, lesson 2 of percent. And this is Mocha. This is a dog. She's cute. I like the ears the best. Really, I don't know if she'd like to hear this, so I'll block her ears. But if I could, I would just keep the ears and get rid of the rest of the dog. The ears are the only part that really matters, okay? You are the wind beneath my ears. Okay, I'm going to put her down, and she is going to behave herself. Lie down. Stay. Stay. Lie down. Lie down. Stay. No smart aleck comments, no throwing of erasers, none of that. You're going to stay there for the next hour. Okay, and what is going on here? I'm wearing a Barcelona shirt. Well, that is my most common type of shirt, so no one should be surprised. It's cold and it's been snowing. I haven't talked about the weather lately. Last week, we nearly had a snow day. I was hoping for a snow day. I kept on waking up during the night and looking at the weather report and looking on the app to see if the schools were closed. And they didn't close the schools, and I had to go to work that day. But it snowed. It snowed like crazy that night, and then a few days later on Friday and Saturday it snowed like crazy, and I was shoveling snow all weekend, but no snow days when it snows on the weekend. So that really just describes my mood. It's cold, I don't want to be outside, I may as well be in here in the basement teaching math, and that's what I'm going to do. So now let's talk about percent. Okay, so there's this type of question that students can sometimes struggle with, but you need to conquer it. It's really not that bad, and my approach to conquering a type of question is to thoroughly analyze the question and ask all those what if questions. So this statement, 30 is 15% of 200. It's true, and it's not a question because there's nothing for us to figure out. It just happens to be true. 30 is 15% of 200. But I looked at that statement and I asked myself, well, how many different types of question can I make out of this for students to practice with? And I came up with 3. Now, why would there be 3? This one, and that one over there, because there are 3 numbers in this statement. And if I remove one of the 3 numbers and give the student the other 2, then the one I removed becomes the unknown that we find. And now you have a math question. So, if 30 is 15% of 200, I can make the question, what number is 15% of 200? That's this question. I'm pretending not to realize it's 30. I want the student to prove to me that it's 30. It's a good question. But instead, I can say 30 is 15% of what number? And in this case, it's the 200 that the student has to figure out. Or 30 is what percent of 200? Now it's the 15% that we have to figure out. So since there are 3 numbers in the statement, it stands to reason that I can make 3 different types of question where I make each of those numbers the unknown that we figure out. So we're not going to answer any of these 3 questions because, let's face it, we already know the answer to all 3 because the answer to all 3 is right there. What I'm going to do is I am going to do several examples of each type of question in this order. So this is the first one, the type that sounds like what number is some kind of percent of something. So that isn't very clear, so you have to know what percentage and the something, but then the what number part is the thing you're finding out. That's what we're going to do first. So I will erase. I'm going to erase all of this. It's a bunch of erasing. And I'm going to get my trusty clipboard and I'm going to start doing some questions. And these ones go quite quickly, so I should be able to get a lot of examples into this lesson, and that's what I want. I always want to have a lot of examples of everything I teach in math, but if something takes half an hour to do, well, in a 1 hour class, you can do it twice. I am hoping to do 18 questions in this 1 hour lesson, of which I have already used the first 4.5 minutes, so I better get started. So here's one. What number is, and this time 40% of, and this time we have 20. So to do the first 5 examples, I'm just going to erase the number here and the number there so that I don't have to spend as much time writing on the chalkboard. Now let's think about how we can figure this out, and there's more than one way of figuring it out. And the students should try to use different methods so that you don't see this whole lesson as just one trick you're learning. It's actually a series of interconnected tricks. Okay, so what is 40% of 20? My favorite way to answer it is to create an algebra situation, but I realize that I am aiming this lesson at students who haven't started learning algebra yet. That's okay, because this is a cross multiplication algebra situation, and I know the students have seen it before, because when you start learning algebra, you realize you've already done a little bit of algebra. That's where we're at. So 40% means 40 out of 100. We know how to do this. We were doing this last week. 40% is equal to another fraction where, because we see of 20, that means that indicates that 20 goes on the bottom over here. And then we're going to put an x there. So I can take this English language question and I can translate it into this equation, which is a proportion, and which we solve with cross multiplication. When you're able to do that, you have what looks like two fractions with an equal sign in between them, and they can be solved with cross multiplication. And cross multiplication is easy and fun. Students like it because they get good at it quickly. So, how did I do that? The 40% tells me both of these two numbers. That kind of helps. And then the language of the question indicates that what I'm looking for is going to be on the top, and the 20 is going to be on the bottom. What number is 40% of 20? That sort of helps me put the 20 into the right place. So notice that the x happens to be in the numerator right now. That won't always happen in every proportion. And it won't always be over on the right side either. We have flexibility in how we build the proportion. But I'm able to translate into this, and this I can solve, and that's what's important right now. So cross multiplication means we do bottom times top equals top times bottom. So bottom times top means one of the bottoms is multiplied by the other top. So I'm going to do this bottom times this top, and that gives me 100x. Then I put my equals, and then the equals top times bottom means I'm using the other top and the other bottom, so that means 40 times 20. I just like to say it in my head, bottom times top equals top times bottom, when I do that transition from the two fractions style into the one line style. Then I start simplifying, because 40 times 20 I can do. So I still have 100x over here. I'm not going to change that. 40 times 20 gives me 800. And yes, of course, use your calculator if you need to. And then when we get here, all we have to do is divide both sides by 100. And cancel the hundreds over here. We have x is equal to, the answer 800 divided by 100 is 8. We have our answer. It turns out that 8 is the number that is 40% of 20, and this is one of the ways of solving that, and we'll use this a bunch of times. But I wanted to think, is there another way that I can take this question and turn it into an equation that I can solve where I'm using a different strategy? So what I came up with is this part, 40% of 20. We've done word problems before, and we've talked about how the fact that of often means multiply in word problems. So 40% of 20, I can write it like this, 40% of 20. So I'm translating the of into a multiplication symbol. And now I know 40% is equal to 40 over 100. And that's multiplied by 20. Okay, so this looks pretty different over here than over there, but we're trying to solve the same question with it. Then, 40 divided by 100, I can simplify it. I can do it in my head, or I can use a calculator. 40 divided by 100 is giving me 0.4. And then I can multiply to get my answer. 0.4 times 20. Now that might not be that easy to do, but we've studied our decimals. We can say, oh, well, this is like 4 times 20, which gives me 80. But I have a decimal digit here. So I have to have one digit in my answer to the right of the decimal, which means I actually have 8.0 or 8. My answer is 8. And we got the right answer this way, we got the right answer that way. So if you prefer doing it this way, then that's okay. If you prefer doing it that way, that's okay. What I like best is if a student is able to do it either of these ways, and that student has a bigger over-encompassing understanding of how this question works, and that student is pretty powerful in solving questions like this. Okay, so sometimes I'll do it one way, sometimes I'll do it the other. I really like the cross multiplication. I tend to use it more. Let's do some more examples, because now I've already used 10 minutes and I'm still only on the first example. I better speed it up. So it's time for some erasing. I'll erase all of my both answers to that question, and I'm going to erase the 40, and I'm going to erase the 20, and now I can quickly get a second example in. What is 75, what number is 75% of 60? Okay, at this point I don't need to carry this all the time. I'm only looking at it to get two numbers to move on to the next question. Okay, and I'm going to use that cross multiplication approach. 75% means 75 out of 100. We know that. I build my proportion. Over here, because it says of 60, the 60 is going to go on the bottom, the x goes on the top. So when questions are asked in this style, when the what number is what we're looking for, and the of 60 we know and the percentage we know, the x is going to land on the top. So now I do cross multiplication. 100 times x is equal to 75 times 60. I have to do 75 times 60. I'll grab a calculator. I don't want to show off that I can do it in my head, at least not this time. But 75 times 60, 4,500. So I have 100x equals 4,500. I divide both sides by 100 so that I can isolate my x, which is always the goal when I'm doing algebra, because this is a nice, easy intro to algebra. My x is now alone, and it's equal to whatever 4,500 divided by 100 is, and I can simplify that with a calculator if I want, but I can also do canceling and realize x is 45. I have my answer. I'm not doing it a second way. I'm not always going to do it two ways. So I'm getting good at doing this type of question, and I hope you are too. And the best way to make sure is to do another one. So that second example was definitely faster. I'll erase all this. I'll erase the 75. I'll erase the 60. I'll write in the next question, the numbers for the next question, which are 20% and, 440. Okay, like usual, I am gradually increasing the challenge simply by playing around with different size numbers that are round and then followed by numbers not so round. Maybe even getting some decimals into some of these. We're not afraid of decimals. So I'm going to do this one, but first I'm going to take a sip of my fizzy water, and I'm going to remind the students that you should always be ready to have a stretch, or just get up out of your chair and sit down again whenever you need to. When you are trying to study math for a whole hour, it's long, and a sip of water certainly doesn't hurt. This time it is ginger ale flavored fizzy water. It's not ginger ale, it's fizzy water. It's flavored like ginger ale. Okay, now I'm going to do the same strategy. 20% means 20 over 100, and that is equal to something out of 440. And I'm trying to say out loud the translation that goes in my head when I go from this to this, because it's a skill that students have to practice. And there's that x on the top again. Just to show that it doesn't always have to be done this way, well, if I wanted, I could put the, that didn't do that pretty well, I could put the 20% over on the right side, and then the 440 is still going to be on the bottom. The language implies that the x is, so this is actually the same as that. It's sort of a mirror image, but whether you arrange it so that your x is on the left side or the right side doesn't matter. So long as it's arranged correctly, it will still work. So I will ignore this one, and I'll do this one just to prove that it does work. Top times bottom equals bottom times top, so I'm going to take the x in the 100. 100 times x has to be equal to 20 times 440. I have to simplify that. Am I going to show off that I can do this in my head? Yes. I feel like doing it this time. So 20 times 440, that's a little tricky, but I can do 10 times 440 and then just double the answer. 10 times 440 is not that bad. It's going to be 4,400. So if I double that, it's going to be 8,800. And then I divide both sides by 100 so that I can cancel these and isolate my x. And 8800 divided by 100 is 88. I have my answer. I would have gotten the same answer if I did this one. It's really the same approach. X equals 88, and then he sneaks over and looks at his notes to make sure, because I did write down the answers for all of them just in case. And yeah, 88 is the right answer. This is going really well. Oh, how are we doing for time? If I'm not careful, I might get through all 18 questions and still have time left. That is a good sign though. It means that this math isn't that hard to take, and I hope the students agree. So let's do another example. But I am going to throw one little tiny curveball into this lesson as part of those 18 questions, and that might take a little longer. We'll see when we get to one of those. I'm erasing the 20, I'm erasing the 440, I'm putting in a new question, and the new question is, what is 16% of 250? Okay, so, I tried 40%, very round number, a multiple of 10. I tried 75%, very round number, a multiple of 5. Then I did 20%. Oh, now 16%. Oh, 16, not quite so round. Is it going to make it harder? No, that's the point. That once you know a technique that works, the technique keeps working. Even if you start putting trickier looking numbers in, the technique, the tools still do the job. Okay, so I'm going to do this style again, where I put 16% is equal to 16 over 100, but I'm choosing to put it on the right side of the equal sign. And then what number is the x, and the 250 should go on the bottom. There's the logic. Well, it always works this way. When the question is phrased this way, when I turn it into this equation, the x keeps on being on the top. Left side, right side, there's more than one way of showing it, but it's on the top. Now, cross multiplication. 100 times x is equal to 250 times 16, or 16 times 250, whichever one you feel like putting first. And that's going to be, I'm showing off, doing it in my head again, but remember, we are allowed calculators. 16 times 250, 4 times 250 is 1,000. That's a nice easy one. And 16 is 4 times 4. So 4 times 250 is 1,000 times 4, 4,000. 100x equals 4,000. So even though we had 16, not a round number, we still ended up with a bunch of zeros here. It's not going to be a very difficult one to finish. We're going to divide both sides by 100. Cancel, cancel. 4,000 divided by 100. Cancel 100 top and bottom. It's giving me 40. My answer is 40. And I sneak over and look at my answer key. Yep, I got it right. Okay, so that worked. One more like this before I change the way the question looks just a bit. I'm not switching to the second type of question. I'm still on the first one. I want to do 6 examples with this type, and this is the 4th. Okay, next one. Let's erase. Erase the answer. Erase the 16 and erase the 250. How about, 31. What is 31%? So that's not a very round number. Of 80. Okay. I'm going to go back to putting 31% is equal to 31 out of 100 on the left side, just because really that's the way I tend to do it. And on the other side, well, the of 80 means the 80 is going to be on the bottom, and the what number is the x going on the top. We knew the x would be on the top. That's the way it keeps working with these ones. Cross multiplying 100x equals 31 times 80. Do I dare do this in my head? No, I don't dare. I'm going to use the calculator. 31 times 80. 31 times 80 is 2,480. 100x is therefore equal to 2,480. I will divide both sides by 100, and I'm dividing by 100. You notice how I keep dividing by 100, the way I've been setting these up. And dividing by 100 isn't very hard. And whenever I do the top times bottom equals bottom times top translation from this line into that line, I keep on getting 100x. It's happened in every single example so far. Why? Slow down and stop and think about why, because when you know the why, you feel like you understand. Because it's a percent. And the percent always turns into some number over 100. And the way I'm asking these questions, I keep on having the 100 on the bottom of one side and the x on the top of the other. It's not a coincidence. It's happening because it's logical that it happens. And then, of course, hundreds have a way of making math problems look easier than complicated numbers like 27,342.987 do. So 100x, it's an easy introduction into this math. It's good. Cancel, cancel, not finished. X is equal to 2480 divided by 100. Okay, first I'm canceling 10. So it's 248 divided by 10. Uh-oh, I got a decimal. 24.8. And of course, use the calculator if you need to. What's the matter with getting a decimal? We were doing percent. Why do we have a decimal? We finished with decimals. No. We learned decimals before percent for a reason. Because there's a big overlap between understanding percent and already understanding decimals. That's one reason. So I want the students to realize, well, there's nothing to be afraid of when you get a decimal. And even if I were to put a decimal here and a decimal there, the technique would still work. Maybe I'll try that at the end if I do have extra time at the end. Try to make one where I put decimals all over the place, and we'll find out if the process still works. But for now, I've done all of the regular problems of this type, except that one where I want to ask the question a little differently. So remember what this looks like. What number is 31% of 80? The what number keeps on being the thing I'm asking for in all the questions we've done so far. Now I'm going to write a word problem on the chalkboard, and yes, of course, writing word problems takes a while, which is one of the things that eats up the time. So I'm erasing the whole question now this time, instead of just erasing the numbers from it. And what was the word problem? Okay, it'll take a little time for me to write this. Where do I want to put it? I'm going to put it here. There were 850, that's an R, there were 850 strawberries after a day. Strawberries. Why did I pick such a long word? After a day of picking them. Okay, that's not the most perfectly grammatical sentence, maybe. But I could also say there were 850 strawberries after a day of picking strawberries. I don't know, it doesn't necessarily sound that great either way. So I'm just going to stick with them. I'm not even finished. I was allowed this little line is just there to help me find the end of the zoom rectangle, so I'm leaving it there, but no, it's not a comma or anything like that. I was allowed to bring home 12%. Bring home 12% of them. There's that word them again. Not even finished. How many did I bring home? Okay, so that's not too long. One more little sentence. How many strawberries did I bring home? Okay, finally it's there. Now, like all word problems, we have to translate from English into math language. But the numbers are key. So we look at the numbers and we see how they're important, and we try and figure out what equation will solve this. I want to know what 12% of 850 strawberries was. I can sort of summarize it in my head that way. So I can build this equation. 12%, which I know is 12 out of 100, would be how many strawberries out of 850. And what we're seeing is that I created a word problem. We're translating it into an equation does exactly the same thing that we did with that easier, that smaller, less words version of the questions we were doing before. Basically, I made up another question that is the same as the previous 5, because I know the percentage, which means I know both of these numbers, the 12 and the 100, and I know the total number of strawberries, which is why I know this 850 needs to be on the bottom. I'm going to bring a smaller number of strawberries than 850 home, but how many strawberries will I get to bring home? This equation will answer that question. So we can see how the word problem can be translated into the same type of math equation that we've already gotten good at doing. And this is something I want to encourage the students to feel some confidence about. Of course, I will finish and answer the question. So 100x is bottom times top is equal to top times bottom, 12 times 850. And I'm not going to show off. I'll use the calculator to do 12 times 850 on 12 times 850 equals 10,200. And then I divide both sides by 100. These cancel. X is equal to 10,200 divided by 100. Cancel, cancel, which is 102. And because it's a word problem, do not forget I have to provide a unit of measure in my answer, or else my answer is not complete. And the unit of measure is strawberries. Why couldn't I have just chosen apples? Why do I pick these long words? I don't know. I don't think when I'm writing out my lesson plan with a pencil and a clipboard about how much trouble it's going to be write out these ginormous words on the chalkboard wall. But anyway, we got to the end of the question. We did a word problem. It works the same as all the previous examples before, and we see the power of being able to create an equation like this and know some very basic algebra steps to be able to solve it. And don't forget your unit of measure. No, 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 don't ever forget that. It is time to move on to the second type of question that I referred to way back at the beginning of the lesson, which means I have to do some erasing and I have to check the time. Now, I'm at 27 minutes, which is almost halfway through, but I did use time at the beginning for the intro and, you know, playing around with the dog and showing off her ears and talking about the snow. So I think I'm doing okay with time, and I should be able to fit all of these questions in. I am determined to fit all of them in and fit in that Challenger one I talked about where I'll put a bunch of decimals all over the place. Okay, so it's time to erase. After all the trouble of writing out that long word problem, here I am 2 minutes later having to erase it. Thanks to the magic of video though, it will never actually completely disappear. Okay, second type of question. Okay, so now, which of the numbers in the original 3-number statement is the unknown is changing. And this type we're going to do next is going to be exemplified by my first one. 44 is, so the last one started with what number? Now I know that number, it's 44. 44 is 20%, aha, I know the percentage again, of what number? So the phrase what number happened in both, but instead of being at the beginning, now it's at the end. Okay, I need to translate this into an equation. And this I'm going to do it twice again. But I'm going to start with my cross multiplication way, my favorite way first. So I look at this and I see, well, I have 20%. I'm putting the 20 and the 100. I can put the equals on either side of that. It doesn't matter, so I'm going to put it on the right side. And then I need another fraction. So 20%, okay, 44 is 20% of what number? What's implied by the way the wording is different is that the what number, the x, is going to be at the bottom. And all the other examples is on the top. 44 is going to be on the top. 44 is a smaller fraction of what number the language indicates. No, 44 has to be the numerator. And now we solve it the same way, except I am not doing 100 times x like I did in all those previous examples. Now I happen to be doing 20 times x. Top times bottom equals bottom times top. Top times bottom, 20 times x equals bottom times top, 100 times 44. But the fun of knowing how to do this is, well, is this going to be any harder? No. At this point, it's not different anymore. Question asked is different. Little things happen differently as we translated it, but now it's not different anymore. I have a single equation on a single line with no more fractions. I have to multiply these two. 100 times 44 is going to be 4,400. and I have 20x, and I have to divide both sides by 20 now, so that I can cancel these. My x is isolated, and okay, 4,400 divided by 20, I'll cancel 10, so it's like 440 divided by 2, and I can do that in my head. It's 220, I have my answer. Is it supposed to be 220? Yes, good. And I'm going to do it again. Again, reminding you that there is more than one way of creating an equation, and if you're familiar with more than one way, then you really feel like you can handle anything. So what's the other way? 44, remember, has a tendency to be the equal sign when you are translating from English into math. So 44 is like 44 equals. I'll put the equal sign more beside the 44. Is that fitting on the rectangle? Yes. 44 equals 20%, but we know that is 20 out of 100. No, I don't want to write it like that yet. I'm going to do more translating as I go. 44 is 20%, and of has a tendency to mean multiplication when we translate from English to math. And the what number is... Oh, I was looking at the wrong answer. No wonder I was confused. 44 equals 20%. See, I don't want to put the x for multiplication because I want to use x for my variable. So I'm going to say times x, and I'm using that dot for multiplication instead. Now, this is awkward because I have a percentage in the middle of an equation, and we know what we do with percentages. We convert them into either decimals or fractions. So I'm converting this time into a decimal. 20%, that's 20 divided by 100. I'll write it like that. So I'm showing an extra step here. But when we do this, we've done this before. Dividing by 100 is one of those easy ones because you jump the decimal. So 44 equals, if I take 20, the decimal would be here, and dividing by 100 means I'm jumping that 2 places to the left, times x. So therefore I have 44 equals 0.2x. I stopped drawing the x the same way, but it's still my unknown. I'm dividing both sides by 0.2. These cancel. Need more chalk. Give me some more chalk, thank you. X is isolated. And 44 divided by 0.2, okay, I could do that in my head, but I'm not going to. 44 divided by 0.2 is 220. And my x ended up on the right side, but we know that doesn't matter. If 220 equals x, it means x is equal to 220. The equal sign's like a mirror in that way. You can say it forwards, backwards. Okay, so I don't know if anyone finds this easier. It's just different. But it's giving me the same answer, so it works. Okay, I'm going to mostly stick with this style through the whole lesson. And now it's time. I went a long time because I was introducing a new style of question, and I answered it twice. I'm looking at the time. So now I want to do several more. Second, third, fourth, and fifth examples of questions that are asked in this way. So we know how that works. We get to take less time because I don't have to erase the whole question. I'm just going to erase the 20 and the 44, and now I can plunk in the numbers for my next example, which are going to be 31 is 25% of what number? And we're ready to go into our equation right away. So there's the 25%. I'm going to put 25 out of 100 on the right side of the equals this time. And then 31 is 25% of what number tells me that the what number, the x, should be on the bottom. And that's going to keep happening all the time with the question asked in this way. So the first way we kept on getting x's on the top. And now this way we keep on getting x's on the bottom. And it doesn't bother us because at this point we just cross multiply. So we have 25 times x equals 31 times 100. 31 times 100 is an easy one to do in our heads. It's 3100. I have to divide both sides by 25. Cancel, cancel. X is isolated, and 3100 divided by 25 is going to be 124, but I'm going to double check with my calculator, which has chalk dust all over it, on 3,100 divided by 25. Yes, 124, and then I look into my little, 124 sitting right there. Okay, I did it right, I didn't make a mistake. Good, so that did not take long, did it? So let's do, is it 3 more? Yes, 3 more examples before we try a word problem of this style. So erase all this, erase this, erase this, and we're ready to go. 6 is 12% of what number? It's tempting to go too fast and say, wait, 6 is half of 12, half of 50, it must be 50%. But no, that's not what's being asked. 6 is 12% of what number? Let's be careful, let's translate. 12% has to be equal to, I'm choosing to put the 12% on the left side this time again. 6 is 12% of what number? The what number's on the bottom, that happened. 6 is on the top. Cross multiply, 12 times x equals 6 times 100. I wonder how many students actually say in their head, top times bottom equals bottom times top. I bet very few of you do. I never did until I started teaching it. I wanted to be able to explain how I was going from here to here, and that's what came up to me in my early years as a teacher, and I like it. Top times bottom equals bottom times top. Yes, I made that happen. Okay, 6 times 100 is 600. That's easy to simplify. And I'm dividing both sides by 12. This time I'm not going to show off. I'm going to get my calculator. 600 divided by 12 on 600 divided by symbol 1, 2 equals 50. X is equal to 50. Okay, well, it's the right answer. 6 is 12% of 50. Think of other ways that makes sense. Now, I'm not showing another way to find the answer. Now that we know the answer, a way of, say, verifying or just to think about it. 6 out of 50 equals 12 out of 100. So what I did here is I took this thing, but since I know my answer is 50, I just stuck, well, I am verifying. And 6 out of 50, well, I could multiply that by 2 over 2 if I wanted. And 6 times 2 is 12, and 50 times 2 is 100. Okay, this verified. Maybe looking at your answers this way and verifying this way will help. It might not be a bad idea for a student to do that. And of course, there's other ways. I could have reduced the 12. I'm being a little bit over analytical, perhaps. I write the 6 over 50 equals 12 over 100 again. Writing this thing, but with the answer in place of the x. And this time, instead of expanding 6 over 50, what if I reduce the 12 over 100? 12 divided by 2 is 6, and 100 divided by 2 is 50. So I found 2 different ways of verifying, and both of them involved using skills that I was getting good at when I was learning fractions. So fractions and decimals both come in awfully handy while we are learning percent, which is one of the reasons why we learn fractions, then we learn decimals, and now we're at percent. I like it. I like that question. But my mouth is dry. Okay. I'm not going to get her attention and distract her, but we have a very well-behaved dog in the room, and I'm just afraid to look at her because I don't want to jinx it. Okay, next question. That was 6 is 12%. I'm going to erase all my verifications and my answer, and I'm going to erase this 12 and this 6. Next question, 33 is, what's that? Oh, 150%. We hadn't been talking about percents bigger than 100 so far in this week's lesson, had we? But we did last week, and we learned that there is nothing to be afraid of in having a number like 150%. So I'm building my equation. 150% means 150 out of 100 has to be equal to a fraction where the what number is the x that's going to be on the bottom and the 33 is going to be on the top. Makes sense? cross multiply 150x equals 33 times 100. 150x therefore equals 3,300. I'm dividing both of these by 150 so that I can cancel these. X is isolated, and 3,300 divided by 150. I will get the calculator. Lots of chalk dust in this room. I wonder why. Okay, 3,300 divided by 150. 22. 33 happens to be 150% of 22. And you think of 33 and 22, they're both double digit letters. Don't know what word that to use to describe that. But I know that when I think of the multiplication tables, the multiples of 11, we learned those really early on, and we're proud because the 11s are over towards the bottom right of the multiplication table where all the hard ones should be, but we realize, hey, that's not hard, we're good at it, we got a whole bunch of things because we know that, say, for instance, 8 times 11 is 88, and 9 times 11 is 99, etc. And then we see 33 and 22, and we think about the relationship between those. And does it make sense to us that 33 is 150% of 22? And yes, it does. Okay, that's a cool one. One more like this before I get into a word problem. Nervously, he checks the time, realizes he has nothing to be nervous about, and just forges ahead. Oh, I need to erase this and this. And my last one before the word problem is 51 is 17% of what number? 17%, I choose to put it over on the right side of the equals this time. 17% of course means 17 out of 100. And then 51 is some of what number? Yes, the what number is the unknown, it's on the bottom. 51's here. Cross multiply 17 times x is equal to 51 times 100. So the pattern that kept happening in the first bunch of problems was I kept on having the 100 with the x. And the pattern that keeps happening in this bunch of problems is I keep on multiplying the 100 by some number. And I keep on thinking, oh, that's easy, because it is easy to multiply numbers by 100. 17x is equal to 5100. And now we divide both sides by 17. And x is equal to, is it going to be 300? I think so. Now I can walk over to my clipboard and just check that I was right, but I can also try verifying. So I'm not looking at the clipboard. 51 over 300 must be equal to 17 over 100. But if I multiply 100 by 3, I'll get 300. So I'm going to multiply this by 1, but I'm multiplying it by a 3 over 3 version of 1. And although 17 is not in the 12 times 12 multiplication tables, I happen to know that 17 times 3 is indeed 51, so it verified. Okay, now it's time for a word problem. And that means I'm erasing this. We are finishing with this word problem, our second group of questions, with the second style of asking this whole percent problem that's so flexible. And my word problem is on the other side of the page. So, here he is talking about the craft fair again. I'm always making up fictional craft fairs and participating in them because I like participating in craft fairs. So, my share of the profit at the craft fair was 5%. Okay, let's write it down. My share of the profit at the craft fair was 5%. Period. My share was $61.25. how much was the fair's profit? Almost done. Yeah, now we know where all that chalk dust comes from. That's all settling all over my calculator. Okay, so I have to convert this, like all word problems, into an equation. I'm translating from English to math, and I see my share was 5%. My share was, so I'm saying $61.25 is 5% of something. Right now I'm translating from this longer paragraph into the shorter type of question I just had. So I'm doing the same math. 5% is equal to some fraction. My share is smaller than the fair's profit. I only got 5%. I got a small part. So therefore my share of the 61.25 is the numerator, and the fair's profit is what I'm looking for. And yes, how much was the fair's profit? That's what I'm looking for. So there's my x. And now I cross multiply. 5x equals 61.25 times 100. Now, that's not too hard to do because with decimals, multiplying by 100 is quite easy. I'm jumping the decimal 2 places to the right. So 6125 is what I get when I do 61.25 times 100. And now I have to divide both sides by 5. Cancel, cancel, x is isolated. 6125, 6,125 divided by 5 equals 1225. But that's going to be dollars. So I'm putting a dollar sign, that's my unit of measure, and I may as well put that to make it clear it's dollars, because I didn't get an answer with a decimal in it. So that means the decimal is at the end of the 1225, and it makes sense when you think about my share was 6125, but that's only 5%. That's a very small fraction. And 6125 would be a very small fraction of $1,225. Is that the answer? I actually don't know. When I wrote in all my answers, I forgot mainly to put the answers of the word problems, but oh look here, I did show the answer. And it is $1,225. Hooray! The process works. I'm not surprised that it works. Okay, now we're moving on to the third and last type of question, and I have about 12 minutes left, so let's just get busy. Third type of question, aha, this is this type. 16 is what percent? Aha. And the other ones, the percent had been given in both of the other types of question. Now the percent is what I'm looking for. 16 is what percent of 50? Okay, that's supposed to be a question mark, but since I'm not going to erase it and use it over again several times, I'll make it neater. Okay, 16 is what percent of 50? Okay, so I'm trying to do this again. It's a messy equal sign there. But the what percent isn't as fast to do. When I had like 18%, I'd put in 18 over 100 really quickly. But what percent means I don't know what number is going over 100. But I do know that 16 of 50 implies the 16 should be on the top and the 50 should be on the bottom. Is this making sense? 16 is what percent of 50? Yes, I feel confident that the 50 should be on the bottom. Then I'm going to cross multiply. So again, once we build our equation, the steps of simplification keep being the same, which means that we're not constantly having to do something different. And that helps us feel confidence in our answer, and we get lots of practice. 50x is equal to 16 times 100 if I cross multiply, which is 1600. I divide both sides by 50, and some of us can do this in our heads, and some of us reach for our calculators. I'm thinking 32. Is that the answer? Where's my answers? Yes, but oh, we're asking for a percent. So we want to say at the end, with our answer, that it's a percent. It's interesting how this percent symbol kind of is the unit of measure. Some of these questions, all you're being asked for is a number, so you give the number. You don't need a unit of measure. Word problem, you tend to need a unit of measure. When you're being asked for a percent, make sure you say it's a percent at the end, otherwise people won't know. People won't know it's 32%. And as we learned last week, 32% and 32 are not really the same number. Okay, so now I can do a few more for practice. Let's get into it so that we have time for a challenger question at the end. I'm erasing all this. I'm erasing the 16 and I'm erasing the 50 and I'm keeping that question mark. And I have, there they are, 24 is what percent of 160? Put this down. Let's go. Let's just get into it, okay? What percent 24 of 160 means? I want the 24 on the top and 160 on the bottom. Yes, it's working. And I'll just go quickly and solve it. But remember, we see patterns. So the pattern here is we keep on multiplying something by 100. That's happened again. 160x is equal to 24 times 100. 24 times 100 is 2,400. We divide both sides by 160. Cancel, cancel. X is isolated. 240 divided by 160. I'll just get the calculator. Not 240, it's 2,400 divided by 160. 15%. Okay, I have to watch it. I do not want to forget to do that because I'm going to confuse some students if I do. Yes, I need to say it's a percent. That was fun and it was fast. And I'm going to do another one. $165 is what percent of 500? 165. Oh, weird big numbers this time. Okay, so what percent and 165 of 500? More chalk, please. Oh, this chalk is ending. Okay, I'm getting rid of this one. Oh, fortunately, I have a brand new chalk piece lying there. Let's go. Okay, so I have 500x equals 165 times 100. And it's a big number, but it's multiplying by 100. It has a tendency to not be that tough to do. 500x, divide both sides by 500 so that I can cancel these x's alone. 165 divided by 16,500 divided by 500. If I cancel, it's like 165 divided by 5, so that's going to be 20, 33. Is it 33? You double check. No, it isn't, because it's 33%. So yes, my division was correct. Don't forget the percent symbol. Ask for a percent. So I want to give them a percent. Okay, that went fast. That's good. Let's erase. And time, not bad. I think I can fit all of my examples in. 63 is what percent of 525? I'm going to do the what percent on the right side, just because I feel like it. So the 63 of 525, yes, this makes sense. Cross multiplying, that's a little messy. 525x is equal to 63 times 100. Here I am multiplying by 100 again, so it's 6,300. Ooh, 525x. I have to divide both sides by 525. We're getting to a position where even I don't want to try to do it in my head. Cancel, cancel. X is isolated. 6,300 divided by 525. Ooh, 6,300 divided by 525. 12%. Oh, so it turns out 63 is 12% of 525. The numbers get a little crazier looking, but the technique just works. One more before I do a word problem. Nervously double checking the time. one more before I do a word problem. The real issue here is how long it takes to write down the word problem. And I don't want to skip it, I like it. Okay, so we have 8.5. Ooh, there's a decimal inside the question. 8.5 is what percent of 340? So we're really exercising these muscles where we know that it doesn't matter what numbers we work with, our technique works, let's just go for it. What percent is x out of 100? 8.5 is my numerator, 340 is my denominator. Cross multiplying 340x equals 8.5 times 100, which is 850. 340x, divide both sides by 340. Making sure that I copied the question down right, but I did. Divide both sides by 340. Cancel, cancel. X is isolated. That I can cancel easily, but I'm not going to try and do 85 divided by 34 in my head. So, 85 divided by 34, which of course is the same thing as 850 divided by 340, is, 2.5. 2.5%. So I had a decimal on the question and a decimal on the answer, and it didn't stop me at all. Good. Okay, word problem time. Let's see. Ooh. Erase this whole thing. The truth is, of course, if I go over by a couple of minutes, well, I am allowed. And I do that quite often, actually. Okay. I'm not going to write the first sentence because it's long and it doesn't have a number in it. I took a share of leftover juice boxes from the sports banquet to school to share with my classmates. So we just have to remember, there was a banquet, I went to it, there was leftover juice boxes, I got them to bring to school. Okay, I brought 55 boxes. Out of a total of 220. What percent of the boxes did I bring to school? And of course, no one's going to be surprised to realize that this is going to create an equation, going to be translated into an equation that works the same way as the ones I was just doing. Okay, so what percent of the boxes, what percent means what number out of 100? And I got 55 out of a total of 220. It's really clear the 55 should be on the top and the 220 on the bottom. And now I'm quickly going into the cross multiplication part. Times 100, of course, is 5,500. Divide both sides by 220. Cancel, cancel. X is isolated. 5,500 divided by 220 is 550 divided by 22, which doesn't even seem any easier, actually. So I'll go back to the 5,500 divided by 220. 25%. So if there are 220 juice boxes left over, and I get 55 of them, it means I got 25%. And some students would have a good familiarity with numbers and realize, yeah, 55 times 4 would be 220. Yeah, and that's, 25% is a quarter of, it works. We're right, and we even have percent in our answer because it's our unit of measure, because that's what they asked for, the percent. Okay, so I do have time. How much time? I do have 38 seconds to try to do, okay, I'll give myself an extra minute. So I have a minute and 38 seconds to try to do a sort of a challenger question. I'll make it like the middle ones. So the middle ones, on the first side of the page, are the ones that are number percent of what number. Okay, so I'm going to do the is, I'll write the percent symbol and the of what number part. Mixing up my uppercase and lowercase, but never mind. Okay. And I want it to be challenging. I want to put weird decimals. Okay, how about 3.7 is 4.2% of what number? Question mark. I didn't do this before, I just made it up, so I don't have the answer on there anyway. I may as well not be carrying it. 4.2% means 4.2 out of 100, and having that decimal in there doesn't bother me. I know what it means. Of what number means that's one of the ones where my unknown, my variable, is in the denominator, and the numerator is going to be 3.7. So is it harder? Even the translation doesn't feel harder. I just have to write a couple of decimals. Nothing else is new here. I'm doing the cross multiplication. 4.2x equals 3.7 times 100. And 3.7 times 100 is going to be 370. Yes. 4.2x. I'm dividing both sides by 4.2. 4.2. Cancel, cancel. More chalk. X is isolated, and I will use the calculator for this, and I may get in a long decimal because I made up the numbers at random, and that'll happen sometimes. 370 divided by 4.2, 88.095238.1, so I have to round. It might actually end there. It's kind of ambiguous whether it would keep going, because it's just about the size number that's the biggest number that will fit in the calculator, but I don't want to write 7 digits after the decimal. I'm going to round. So 88.095, I'm just going to call it 88.1. I round it up. And I'm finished. I don't have to put a percent because the 4.2 was the percent. So what number? The X that I was looking for, 88.1. Messy because of all the decimals, but it worked because the technique works. Okay, so how much did I went more than 2 minutes over the hour I planned. And this dog was asleep, so she's going to be all groggy right now. She is the wind beneath my ears. Or maybe I'm the wind beneath her ears. Oh, I nearly dropped her, oh no! Okay, there, let's get those ears going. I like to do this flapping of the ears thing. It's hard to do. Point the dog at a camera at the same time. Whoa, I nearly knocked the phone over. Okay, never mind. That is a very inglorious, awkward ending to this lesson, but otherwise it was a lot of fun, and I look forward to the next one. Goodbye.